Good morning. I'm Frances Arnold, co-chair of PCAST, and I'd like to welcome all our PCAST members and the public to this virtual meeting where we're going to discuss PCAST's report on artificial intelligence and the possibilities it opens for science, as well as the challenges we have to navigate in order to derive the full benefits of this powerful technology. So hang on to your hats, friends, because the future is here. This meeting is being live streamed to the public and it's being recorded. The recording will be available by next week on the PCAST website. And please note that the PCAST meetings for May and July will also be virtual. Dr. Arti Prabhakar, the President's Science Advisor, will now make some opening comments.
Hi, everyone. Great to be here to talk about the PCAST AI report. I wanted to just provide a little bit of context about the work here in the White House on artificial intelligence. It lit up last year as AI became a huge priority for the president and for Vice President Harris. In that work that we did during the course of last year, the president met twice with PCAST, specifically on AI. And one of those sessions was actually dedicated to the subject of this report, which is how is AI transforming research? And we had a very lively discussion in that session. Some of the topics that ended up in this report were surfaced at that time. But as I think we've discussed with PCAST earlier, in the course of the year, a number of actions came out of the White House, culminating in an executive order, a very broad and comprehensive executive order on artificial intelligence that the president issued at the end of October last year. And it addresses AI broadly. It's looking both at actions we can take under existing law to manage AI's risks, doing the work to set the stage for using AI to achieve big things. One specific deliverable that executive order called for was for PCAST to do a report on the topic that had been the subject of such a lively conversation with the president a few months earlier. And that's the background for this report. And I think that really tells you that this report is perfectly positioned to come into a vibrant set of discussions and actions that are going on in this administration as we get AI right for the American people. So with that, let me turn it back over to Frances and we'll get into it.
Thank you, Arti. So now the co-leads of our working group, our AI working group, Terry Tao and Laura Green, will present the report, and after that, we'll have a discussion with members of PCAST. Terry and Laura.
Okay, thank you very much, Frances, and thank you for the opportunity to present this report. Next slide, please. So this is our working group on AI. We've had an excellent group working for the past year or so on all kinds of AI issues, although currently this report is focused on applications of AI to science. So we've had many great contributions, both from PCAST members and from the excellent support staff. Next slide, please. We've been consulting with many experts in government, industry, and academia, again, over all aspects of AI, and most recently on applications of AI to the sciences. Next slide, please. So as Arti already mentioned, our report is in response to the President's executive order on AI from last October. In that report, in that order, PCAST was tasked to report on the potential role of AI, particularly given recent developments in research aimed at tackling major societal and global challenges. The executive order also covers broader impacts of AI outside of research, for example, to national security or education or labor markets. These were tasked to other agencies and groups and are beyond the scope of this report. Okay, next slide, please. So we found that there's significant synergy between science and AI. On the one hand, AI technologies are starting to remove many of the barriers that make scientific research slow, expensive, or restricted to a small number of experts. Conversely, the fundamental science of AI can mitigate errors, biases, and other potential harms of AI. Furthermore, our existing scientific values, such as validation, reproducibility, and openness, will help develop a culture of responsible use of AI methods in science, which, as we'll discuss later, we believe is a very strong necessary component for proper deployment of AI in this area. So all in all, we believe there's a strong use case for AI tools in science. Next slide, please. So we'll turn now to examples of how AI is transforming science. We've seen that AI is already actually transforming pretty much every scientific discipline and will transform every aspect of the scientific workflow. We're going to briefly give 8 examples here of scientific fields that are being transformed, and we've grouped them into 3 kind of categories, representing 3 different ways that AI is changing research. Firstly, AI algorithms are identifying promising solutions to scientific problems. Secondly, AI models are accelerating and enhancing more traditional simulations and models. And thirdly, AI models are allowing us to analyze new types of data in ways that traditional data science methods find difficult. So these are just examples. We'll be happy to discuss each of them in more detail if requested. And these are and a full report goes into many other examples of disciplines that are being transformed in many other ways than the 3 listed here. There's a few just listed below that you can read. Okay, next slide. Thank you. So starting on how AI is being used to identify candidate solutions, in the area of material science, AI models have already been successful in predicting millions of new stable materials that have been automatically synthesized or that can be automatically synthesized in a laboratory. So, of course, the purpose of material science is to discover new materials that are useful for various purposes. But the most fundamental property of a material in order to be useful is that it is actually stable. So we have at least figured out how to generate stable materials, and so this is an important first step. In the future, we hope that these AI models can predict really useful new future materials, such as room temperature superconductors or new battery materials for electric vehicles. Of course, there have been many candidates proposed already, but fabricating and testing these materials is very expensive. And so if AI technologies can reduce the number of candidates needed before we find a successful one, this will save a lot of time and money. Okay, next slide, please. So moving from inorganic chemistry to organic chemistry, AI models have also been successful in identifying new treatments in the area of drug design. For example, it has identified new antibiotic compounds, including the one here, I think is called halicin. The discovery of new antimicrobial mechanisms and used to design vaccines and targeted therapies, for example, ones that block the binding regions of viruses. The technology will keep improving. We hope in the future that AI-assisted therapies for cancer and autoimmune disorders will become a reality, and we'll be able to use AI to understand deepen the understanding of the mechanisms of antibiotics and antibiotic resistance. Okay, next slide, please. As a third example of AI providing solutions is in the area of semiconductor design. So AI tools are already being deployed today by chip manufacturers to generate initial circuit designs for chips. So semiconductor chips have become a lot smaller and a lot more complicated, and actually designing the integrated circuit in a way that meets all the design specifications is quite a non-trivial task. And then you have to design it, fabricate it, test it. Again, AI tools can be used to shorten the cycle and save time and money. In the future, we actually expect AI tools to take over almost all the lower level chip design tasks, leaving designers to focus on high level direction and improve their productivity by at least an order of magnitude. Next slide, please. So now we turn to some ways in which AI is being used to accelerate modeling. So one area is in climate science. So currently, weather forecasting or climate modeling requires an enormous amount of supercomputer time to just run the simulations, basically just simulating the fundamental laws of physics. But AI models, which are trained from data, can bypass the sort of first principles simulation. And in some cases, it can create simulations of comparable accuracy at much faster rates, in some cases, even as much as 1,000-fold speed up. Although I should say that simulation is only one aspect of climate science. For weather forecasting, for instance, data gathering and data assimilation are still major bottlenecks, and these have not yet been greatly accelerated by AI. But nevertheless, AI is making significant contributions to the subject. In the future, we hope that to be able to create what are called whole Earth models, which would combine both traditional and AI models with real-time data, and not just cover climate processes, but also environmental processes and human processes to create a holistic model of the Earth that could be used for many applications, such as catastrophe modeling, water management, or greenhouse gas monitoring. Next slide, please. Another area where AI models are beginning to make a lot of progress is in cellular biology. So there have been already great successes, for example, DeepMind's AlphaFold program, to predict the structure and function of millions of proteins, for example, how they fold, and what their function is. In the future, we hope to go larger scale and not just model individual proteins, but actually the entire human cell. And if we have an AI-assisted model of the human cell, this will help unlock the secrets of cellular biology and allow new therapies to be tested in silico, in the computer, rather than in vivo or in vitro. Okay, next slide, please. Another area where modeling has been greatly accelerated is in cosmology. So currently, if you want to simulate a cosmological model of the universe, you have to model the billions of galaxies in the universe, again, from the first principles and laws of physics, and this requires a large amount of supercomputer time. AI modeling, which is based on data, can be a lot faster, allowing us to cycle through many different, many more cosmological models than were possible previously. In the future, we hope that AI-assisted modeling will help us actually discover new fundamental theories in physics. Next slide, please. Thank you. So a third area in which AI is changing science is in allowing us to handle really novel types of data, very messy, unorganized, or non-quantitative data. So this is notable in the social sciences, and in fact, we have a new PCAST working group on this topic group. So, for example, the large language models of AI can be used to analyze non-quantitative data that is not attached to any numerical quantity. For example, large-scale behavioral data in social media posts. If you want to track changes in sentiment, say, in some social media space, AI methods have been quite successful there and creating some really deep insights. In the future, we expect a data-driven social science to enable more effective, responsive, and fair delivery of public services. And maybe our social science group may say more about that later. Another area in which we have a lot of unstructured or complex data is in health and wellness. Already there have been some very promising proof of concepts. So physicians have been able to use AI tools to enable early diagnosis of cancers, for instance, or to detect potential errors in medical care to enhance patient safety. There are non-trivial issues in making this widely deployed. For example, we really have to ensure that patient privacy is protected, but the proof of concepts are extremely promising. In the future, we hope actually that AI can be used to make ultra-personalized medicine broadly accessible. So in the future, we can hope that healthcare can be tailored to an individual's specific genetics, and medical history, and personal preferences, doctor's reports, and so forth, and just combine all that data to provide a much more customized healthcare experience. So these are the examples. I'll turn it over now to Laura for the recommendations and findings.
Thank you, Terry. So far, we've outlined some of our successes and some future possibilities in the field of AI. We're going to move on now to our vision of AI-assisted research and development. And we want to gain the greatest net benefit from AI adoption in science. And we envision 3 broad goals. And that's shown by that triangle diagram here. Number 1 is empowerment of human scientists. Number 2 is responsible use of AI tools. And number 3, sharing of the AI resources. And together, they will help AI supercharge science. 5 recommendations to advance these 3 goals I'll discuss right now. Next slide, please. So for the empowerment of human scientists, AI assistants can be developed to complement and empower human scientists. We're not looking to replace them. AI tools can also be harnessed to produce to process huge streams of data and increasingly manage such tasks as laboratory work, coding, and writing, and therefore can identify promising solutions to specific scientific problems. This will release scientists, human scientists, to then be free to focus on higher level directions. We also envision new ways of collaborating that will be developed, such as human sciences directing a network of interlinked AI assistants and make possible extremely large interdisciplinary and even decentralized project. Next slide. Next slide. Our first recommendation here for empowerment of human scientists is support both basic and applied research in AI that involves collaborations across academia, industry, national laboratories, and federal agencies. Such cohesive work will be very important. There are existing examples. For instance, the National Science Foundation's Materials Innovation Platform is developing data sharing infrastructures while employing AI tools as part of the community building, and they're also invoking other agencies and industrial partners. We can see future projects that will include collaborators to develop next-generation quantum computing qubits, whole cell modeling, whole Earth Foundation models, and also really have a handle on high-quality, broad ranges of scientific databases across many disciplines. Next slide, please. The next recommendation for empowerment of human scientists is encourage innovative approaches to integrating AI assistance into scientific workflows. And we're going to need help from the funding agencies and everyone else. So we'll say some recommendations here, statements of this recommendation. Funding agencies should recognize the emergence of new workflows and design flexible procedures, new metrics, funding models, and problems that will encourage strategic experimentation with new AI-assisted ways to organize a scientific project. And then, although AI-assisted science can be superior to either unassisted human science or the fully automated science that we have also discussed, these tools must always be complemented by traditional human scientific research. Next slide. We're moving on to our second goal, which is responsible use of AI. And this will be in developing the culture of responsible AI use in science, and we'll need to develop that, in which AI outputs are externally verified and protections for private data are in place, and algorithmic bias is measured and compensated for, and models and data are transparent, replicable, open, and explainable as possible. This is a high-level goal. This culture should be shaped by continuous dialogue between physical and social scientists, the humanities, and the policymakers. It's an important bullet. And with the development of sharing these resources, we can develop more lightweight models and shared resources, which will reduce the extreme cost and environmental impact of AI. Next slide, please. We have a recommendation for responsible use of AI. And this is really, in my opinion, to help sustain our scientific method. The recommendation is adopt principles of responsible, transparent, and trustworthy AI use throughout all stages of the scientific research process. These AI tools could strengthen scientific integrity in detecting algorithmic biases, enabling more efficient replication and validation of scientific finding, protecting personal privacy and intellectual privacy rights. Funding agencies in this recommendation should require responsible AI use plans from researchers that would assess potential AI-related risks, including aligning with the principle called out in the blueprint for the AI Bill of Rights and the NIST AI Risk Management Framework as models. Next slide, please. So the third goal is the shared and open resources. We are recommending multiple open source models that are powerful enough for research applications that will emerge, and we won't be dependent on a few private technology companies. And through this shared AI infrastructure, and we list some here, redundant efforts can be avoided, and access to AI for research purposes can be democratized. And the time and resources needed to use these tools can be significantly reduced through this sharing of the infrastructure. And we also see that significant scientific federal data sets can be shared. And these were noted in recent PCAST reports: FEMA data to improve catastrophic modeling, defense satellite data to improve wildfire prediction, healthcare data to make patient safety measures more effective, and more examples. Next slide, please. So our recommendation for our second goal of shared and open resources is expand existing efforts to broadly and equitably share basic AI resources. We very strongly recommend that what is NAIRR, which is the National Artificial Intelligence Research Resource, be fully funded. This is an important first step toward establishing a broader national AI infrastructure of compute, data, practices, and human expertise that can compete with private and international efforts. In the longer term, NAIRR could be used as a stepping stone for more ambitious moonshot programs, as we've mentioned here, the complex systems such as the Earth and the human cell. Next slide, please. Our third recommendation for this third goal, our second recommendation for this third goal is expand secure access to federal data sets for approved critical research needs with appropriate protections and safeguards. We encourage the expansion of the National Secure Data Service Demonstration and the Federal Statistical Research Data Centers with strengthened enforcement of data sharing mandates for federally funded research. We also point out that shared AI infrastructure may make feasible the upgrading of all the raw federal data sets to be more valuable and highly curated databases to democratize the resources so we know what's there and to benefit society. Next slide, please. Our conclusion is this. Number one, scientific research will be radically accelerated by a broad spectrum of AI technologies. And with the right AI infrastructure, this will enable scientists to address urgent challenges. AI isn't perfect, and we know how to mitigate this, and we will stress that when used responsibly, AI can unlock great advantages in science and technology, and perhaps the greatest risk is not seizing the opportunity to lead the world in using and understanding how to wield AI. Thank you.
Thanks so much, Terry and Laura, for a great summary of what is a very deep report. And now I'm going to open this for discussion. Please raise your hands if you have questions, and I'll start off just by asking, I understand this debate between making AI models open source and closed. And one of the questions is, how do you, and you talk about this in the report, how do you make open resources that are also secure? And any member of the group can respond to that.
Jen, did you want to respond to that? Okay, well, so that's one of the things that we do have to work out, that as you open up data resources, you have to understand the people who are wanting these broad resources, and they get a key to get into it. We can't.
And how about for the models as well? Open source models that are also secure.
If I can respond, I think if you open the model, you're making it public, but the model is what the model is. I mean, if it's an accurate model, people have access to that model. Say it's a weather or climate model, they can run it. You can easily cryptographically sign it, so you know that they're running that model and not some altered model. It's secure. I mean, it's always possible that they can fine tune it in a way that it becomes less accurate or has some biases that it didn't have originally.
Right. And there are technologies to protect the data the privacy of the data that's being used to train the data. You can anonymize the data, you can randomize it a little bit. There are experiments of using synthetic data rather than real world data as training. These are not silver bullets, but this is definitely ongoing research that needs to be supported. It's definitely an important concern, though.
Well, I think given the
yeah.
sustainability issues associated with AI training and model building, having shared models and open models is one mitigation for that. So I hope that we'll push efforts to do that responsibly. Jen, I think you have your, oh, sorry, Laura, did you want to say?
I just want to say that that is specifically called out in the NAIR pilot. And so they are calling for open data and they're calling for secure data. And they have called to work across agencies in achieving those goals.
Wonderful. Great. I see some hands up and we'll start with Jen Richardson.
Great. Thanks, Terry, Laura, and the whole committee for this incredibly engaging and illuminating report. I'm, of course, a social scientist, so I'm ecstatic about the inclusion of social science research as a area ripe for discovery with the assistance of AI tools and approaches. And I just wondered if you maybe we could take this moment to provide some examples, maybe one or two, of research that's either already happening that's relevant to the health, wealth, or well-being of the American public that's already being enabled or facilitated by AI tools? Or are there areas that are poised to benefit in the near future with greater incorporation of these AI tools and approaches?
So maybe Eric can take the health and wellness question.
Eric and John. Levin, yeah, both. Thank you, Terry.
John, go ahead.
So it's a great question, Jen. I think let's give maybe two examples where for federal government programs, AI may be helpful. One is that as our social science working group is exploring, we know that AI often with federal government programs, say programs for health or for education, we're very interested in measuring the effect of those programs, and we tend to measure the average effect on the whole population, on a large population. And the machine learning tools that are now being developed and have been developed in the last decade or so are much more sophisticated at being able to break out the effects of different federal policies and programs on smaller populations, and then how to refine those programs so that all Americans benefit more from them. I'll give the second example is actually just much more mundane, which is so many federal programs are very complicated for people to navigate. And we all just filled out our taxes earlier this month. It's pretty complicated to fill out your taxes. There's many, many provisions in them. The documentation is enormous. If you have to go through all the explanation of form, 8235 or whatever it is, it's very complicated for most people to do. And AI tools excel at synthesizing information and presenting it to people in simpler ways, or autofilling reports. And that basic adoption of tools could hopefully over time make many federal programs, student loans, access to different benefits that Congress mandates, much easier to access in the way that we've all gotten used to using these digital tools like the one we're on right now, so much simpler for us to use.
And
Thanks, John. I hope this will be sped up because we all want these benefits. Eric, did you want to add?
I'll just add a little bit that I'm seeing the first wave of AI tools as reducing some of the administrative burden on healthcare providers and clinicians, for example, more generally freeing up time for patient, physician, healthcare practitioner, patient contact. And that in itself, I think, is going to be a big boon to healthcare provision across demographics. On the AI side, of course, there's been intensive work on tools to help us understand bias and fairness, and to track over time the implications and powers of these tools for different groups, different teams, and how tools might be helpful in rural settings versus urban settings and so on. So I'm very hopeful that we'll keep our eyes on some of the issues across people in society when it comes to how these tools differentially are used and can provide value to groups.
Thank you. Let's go to Maria Zuber now.
Okay, thank you. So I'd like to express my appreciation to Laura and Terry and the working group. This report is really top quality. It's outstanding. I'd like to talk a little bit about the issue of trusted data sets, because trusted models are important and trusted data is equally important. And a number of the examples that you used in your presentation were federal data sets, and in these data sets, there are requirements for archiving and peer review, but there's a lot of data outside that the federal government doesn't collect, okay, that is done by the private sector, and of course these need to undergo scrutiny so that they can be trusted, okay. And I just wonder if your working group gave any thought about what a high quality trusted data set means. Obviously, it's going to be different in different sectors, but there needs to be some pathway of kind of giving a seal of approval that a data set can be trusted and is appropriate to include in an AI model.
Right. I think there already are standards for like for ordering for data set to be open and replicable and the provenance tracked. I think one of the great values of having a project like a resource like NAIR is to actually set the standards for like what we actually expect for an open data set. Yeah, so there are like there's something called FAIR. I think the yeah, I mean that yeah, there are best practices being developed. Actually, maybe one of the other
Maybe there are best practices in this FAIR data. You could look it up, findable, interoperable, whatever. But I also want to point out that there are occasionally problems with non-reproducibility in sciences. And having AI to go there and check it and being able to look at the original data and being able to analyze the original data for anybody out there, even a citizen scientist, will only benefit the integrity of data sets.
Yeah, great, thank you.
Thank you. Bill.
Yeah, I think it's important that the report does emphasize that scientists are going to have to learn to use AI responsibly, and that we're in the early stages of that. And I wanted to share with the group that I encountered personally an example of this using a large language model yesterday. I'm doing some work to analyze census data, public census data, and so the privacy doesn't come into it. And I asked one of the LLMs to write me a section of code that could analyze some pretty large quantity of data on a GPU, and it did so, and the code ran fine. And then I asked the language model, I said, I'm worried that your code might introduce biases into the output. How would I check for that? And it gave me a whole bunch of suggestions. And I said, could you write me code to post-process the output of my program to check for these kinds of biases? And it delivered perfectly good code for that. Now, stepping up a level, I think the point is we're dealing with tools that, at least right now, are ethically neutral. They're not necessarily biased in the wrong direction. And so you can ask them to check these things. And unlike human people who write code, these tools don't have pride of ownership. They're just as happy to try to reveal biases that might have incurred as they are to create them. And that's where the scientists are going to have to learn to use them properly, to learn to use them from sort of both sides of the situation. Thanks.
That's an interesting example, Bill. Thanks for that. Lisa Cooper.
Yeah, thank you all for a really an excellent report. I just wanted to build off of Jen's question that was focused on use of AI, social science data, to address some of the public health and the public policies that the government and, that we need to address for the American people. So we've sort of alluded to some of the challenges that might occur with the use of AI to use it in a fair way to inform public policies. But I wonder if one of you could articulate specifically what these challenges are and where you see us making the most progress, as well as the areas in which we really need to invest more.
I don't know, John, if you can take the question.
Yeah, I think John would do a better job of answering
Yeah.
for the Social and Behavior Sciences Working Group.
Sorry, can you say that briefly again?
Well, I just wanted to, we've talked about some of the challenges. I've heard some discussion around bias, algorithmic bias, but I was just wondering if you could sort of articulate what you see as the major challenges are in fair use of AI to advance public policy, and where you think we've made the most progress versus where we still need to do a lot of more work.
So two big areas there. I mean, one has to do with the distribution of data that's available, and that for example, in computer vision, if you're analyzing, one of the famous examples is, as you know, Lisa, is analyzing faces, and there's different databases may have different representation of populations in the underlying data that's used to do facial recognition software. So that, for example, could make it easier for some people to go through a TSA screening if it ever used facial recognition than other people, and other people might get stuck because the software is not as good at recognizing their faces. That's a data issue. And the other is that the algorithms, in the way that they're run and optimized, might favor different populations in various ways that might be hard to know when they're being trained. And perhaps the solution, as Bill Press suggested just a few minutes ago, is to then use other algorithms to check the biases of the first algorithms. And so these things are probably addressable. But this is such a new area of knowledge, and we're only really starting to understand these algorithms. That was a big topic of discussion throughout the working group, as to how to make these models not just more effective, but also not biased, more fair, particularly when they're applied to people.
I just want to add the importance of that you keep the data anonymous. There's so much data that the federal government has. I was astounded to learn a lot of this from Census and other people, and it's going to be very important. But how do you use it and still anonymize where the data comes from? And Terry mentioned synthetic data. We can train models on synthetic data before we actually have to apply it to real data.
Right, but this is also why we stress responsible use as the culture of responsible use as such a key pillar. I mean, if we don't.
Yeah, I want to jump in on what John just said. Also, we have, I mean, per Jen's question and Lisa's follow-up, this growing sensitivity on the limitations of our tools and methods, and aiming AI directly at these limitations is going to be valuable for understanding the limits and also for extending our tools. So as an example, recent work has looked at taking large-scale anonymized logs of people accessing the web on public health-related issues and using that to make inferences about, for example, needs per demographic. You can map the actual data sets that we have to census data to get a sense for when, and use AI methods to tell us when we don't have enough data about a particular region at zip code level, and to sort of understand what data we need to collect. So AI systems can actually start helping us, given some foundation like census data, and overlaying that with what we can sense and see through the various new kinds of methods we have for collecting anonymized data, when our confidence is low, and tell us where we need to invest more in understanding those populations.
Thank you. Bill Daly.
Yeah, I want to start by saying this is a really exciting time, and what AI is doing is really providing power tools for scientists and engineers that empowers them to get work done that they otherwise wouldn't be able to do, and to do more with with fewer people and less computational resources. We see this, in chip design where AI tools help designers and improve their productivity. And we see it in computational fluid dynamics where people can not only run simulations 1,000 times faster, but the results of those simulations are largely insensitive to things like gridding, which can be a huge labor-intensive task if you're using conventional numerical fluid dynamics codes. And I think it's really encouraging that right now the United States is at the forefront of this, but I think that we actually are in a grave danger of losing our lead through underinvestment. And as the report recommends, the NAIR, I think it's really imperative, given the worldwide competitive situation, that the NAIR be authorized and appropriated immediately to move forward. I was just reading the paper this morning that India is investing $1.2 billion, 100 billion rupees in building a national AI infrastructure. China is making huge investments all through Europe. Huge investments are made. I think it's really imperative that if the U.S. wants to retain its lead, that we move forward and do this post haste.
We forgot to mention that NAIR is already functioning as a small pilot program right now with donated resources, but we don't have congressional appropriation for the full funding yet.
Thank you. Andrea Goldsmith.
Thanks very much for this wonderful report. I wanted to follow up on the notion that AI is very powerful for scientific discovery, and the tools that you need are data, which we're talking about, and I think the investment in there is critical for that, but also computational resources. I know that open source models may help, but that's not going to get to new discoveries by scientists. And so how do we democratize the acceleration of science for universities that may not have computational resources or researchers that don't have those computational resources?
Right. So NAIR also provides computational resources. That's part of its tasking. Some of it is donated by the private companies. Eric or Phil might be able to say more about that, actually.
Yeah, well, NAIR is mostly computational resources, and the vision is that people at all universities, whether they be the top R1s or smaller places, will have access to those resources by writing proposals and asking for computational time.
And in fact, the first for the NAIR pilot, there's been a focus on ensuring that regions that don't typically get a great amount of computational resource are getting some priority in looking at the proposals coming in to assist differentially with helping areas that could gain the most from these kinds of resources right now and during the pilot phase.
Is NAIR also pushing the responsible use message?
Yes.
Yes, the first round, in fact, the first call was focused quite intensively on responsible AI applications, fairness, bias, safety, and reliability.
Right.
I just wanted to say, though, if there's proposals that need to be written to get those computational resources, that can be challenging as well. I mean, we already see a lot of burden on faculty in writing proposals. So just a word of caution there that it might not necessarily solve this democratization problem.
Right. Another thing that may help in the future is development of more scientific foundation models that are already pre-trained and made available on platforms like NAIR, and then with much less resource intensive for individual researchers to use. They don't have to train the model from scratch. So that's a longer term goal.
Yeah. Eric, did you have a question?
Yes. Well, my hand's been up for a while. So I was going to answer your original question, Francis, which is talking about open source and concerns with security. With these new powers of AI, whether it's open source or locked up models, they are bringing new capabilities. And our report explicitly put our focus on the frontiers and what was possible. But we did mention at times throughout the report, as responsible co-authors of the report, where there were concerns and where we need to sort of put some attention and work. And one area was in biosecurity, thinking about the powers these systems give us. They also can be used inadvertently or by malicious scientists to do harmful things. Very shortly, we'll be hearing the response to the executive order from OSTP and National Security Council, as well as follow-ups by NIST on, for example, what we need to do to be thinking deeply about how to do new kinds of screening for DNA synthesis to understand when we might see challenges. But in general, I think we're going to have to also put responsibly our scientists and our best efforts to making sure these tools are used in the best ways possible and keeping an eye on possible downsides, whether the models are open source or not open source models. Because just again, with great powers come all sorts of interesting applications. We're very optimistic about the wondrous good things we can expect, but we have to sort of make sure we keep an eye on the rough edges.
Thank you for that comment, Eric. Paula Hammond.
Yes, I'm also very excited about the report and the idea of democratization. Another element of it is the practitioners. The more we are able to educate a broad set of the US population and the tools that are needed in AI, the more likely that we'll have investigators who are asking important questions. And I was wondering if some of the members of our working group could comment on how we can ensure that we are educating broadly on the use of AI and this really powerful tool gets in the hands of many.
Yeah, no, we'll have to change, I mean, I'm a university professor. We have to change the way we educate our students, I think, to how to use AI responsibly. So the first wave of students, they all just turn to ChatGPT to solve the homework questions with varying results. Yeah, so we'll definitely need to train, actually, but here's a place where AI itself actually could be very useful. I think people are already turning to chatbots to not just to sort of get answers to homework questions, blindly, but to genuinely learn. I do see a lot of potential for AI tools to allow citizen science to be much more of a possibility than I mean, it does happen that lay scientists can contribute to a scientific project, but often they don't have the expertise to really sort of make contributions at the highest levels of scientific quality. But if they're assisted by AI, it's quite possible that they can make more substantial contributions. I'm beginning to see that in my own field of mathematics, actually. And so this is actually one of the things I'm most excited about, actually, just the ability of AI to enable citizen science.
Well, and that's because the interface is so easy now, right? You can interface with a model in a much easier way than we could in the past without having to sit down and write out the code to talk to it. But then we need to interrogate the model and understand what the model is doing. Would you say something about that part of it?
Right. So the AI tools would have to be integrated with other technologies. So in mathematics, for example, we have a separate technology called formal verification. Where there's software that can actually formally check whether a mathematical argument is correct or not. And so if an AI generates some piece of mathematics, it could be nonsense. But if you filter it through the formal proof verifier, you can check that it's actually correct before adding it to the collaboration. And so that's another essential component to allowing large-scale collaboration. So not just the AI to allow people to participate, but something that also verifies. Yeah, so this has been a consistent theme. You have to pair the power of AI with the rigor of other verification tools.
Well,
Yes,
how do
Terry,
you do that with materials, Laura?
Well, I think what we pointed out in there is that you need humans involved every step of the way. So right now, no one knows how to design a thermoelectric. No one knows how to design a superconductor. And so one of the things that we're looking at is, can we look at all the materials out there, all the programs out there, and then interview people that have had hunches and have had successes? What is the conscious jump that they had to come up with a high temperature superconductor or a new thermoelectric? We don't have an answer to that. And I think AI can scrub the literature in both materials and computational techniques, and also where people haven't succeeded. Talk to people and get those kind of hunches where people don't publish.
And of course, you also have laboratory experiments as your final arbiter.
And you always go to the experiments. Yeah, that was the line. Nobody wants a theoretical plan.
But you can't make 800 million new materials, right? The experiments, if you generate 800 million new stable materials, how do you sort through the ones that you actually want to make?
There are techniques for that, but none of us in the field of these correlated electron materials believe that the deep mine discoveries are going to help us find these new materials. They'll help in other ways. There's successes in electrolytes. But as far as these kind of correlated electron materials, we don't know, but certainly synthesizing 8 billion is not going to really help. And so, yeah, we need to be more focused in our materials discovery. And we have ideas on that. Some of those are listed in the report.
And if we can just mention the fact that there's also an opportunity for 2-year learning institutions, as well as our 4-year colleges, to bring in these tools, I think we can reach a larger group of people. So there's also a real opportunity for this to be a tool set that reaches late high school, you know, 2-year institutions, and we have a larger number of our citizens engaged.
But then you need teachers who can do it. We're bootstrapping, you know, a real technological change here.
Yeah,
absolutely.
Oh, Dennis.
Thank you. I also agree it's an excellent report, and I especially agree about the importance of providing AI-related education to all members of our society. I also wanted to mention that while obviously the power of AI is vast, we should acknowledge the challenges it poses to current systems of knowledge production and dissemination and the reward systems that support these activities. Just to make myself a little more clear, give you an example, the challenge of attribution and verification is a vexing one in all fields. So guidance on citational practices, preservation of data, related issues of research and integrity are critical for fields far more than obviously science and technology, and also the agencies that support that. So this is not just an NSF, NIH, you know, DOD type of problem, but the National Endowment for the Humanities, the Institute of Museum and Library Science, and so many more need to be in this. Thank you.
Thank you.
Thanks for that comment. Yeah.
Saul?
I was just going to make 2 other educational comments. One is that this is actually a real opportunity for us to step back and remember that we actually have to teach how to think clearly when we're doing scientific analyses, or just in general in our day-to-day lives, and that the kinds of tools that we now have available to us potentially make us armed but dangerous with being able to, you know, prepare what looks like a real analysis, but is just answering the wrong question, or falling into different kinds of standard mental traps that it takes you know, typical graduate students many years to learn how to be watching out for.
You mean we won't be able to just push the button?
For example, right? And I will say that this is actually something that people have started to develop courses in, where they've you know, set up a problem, let people solve it with AI, and then help them see what traps they've fallen into by doing this. So that was one of them. The other thing I was going to say on a positive side, well, I guess that's positive also. Another one is the fact that I think one of the real opportunities that we mentioned in our report is that the AI is actually very good at helping us translate jargon and terminology between fields. And so I think it does not only open up the possibility for people who are outside of the sciences to be able to you know, work with science you know, ideas, but it even offers people in any one sub area of science the possibility of working with other sub areas of science, because that's as big a barrier often. And so I think that that's actually going to be quite exciting to see what happens as we are able to, you know, understand each other a little bit better and do cross-disciplinary work.
I really want that. I want the Google Translate for biology, or the Google Translate for chemistry, and especially the one for math, Terry. Have you got that?
We'll work on it, yes.
Okay.
It's a problem.
Eric, I think you might get the last word here.
And maybe it's a useful word. And this is a call to AI model creators and AI researchers, as well as to scientists, that we are not at a fixed point with technology. It's moving along, and scientists have their needs and requirements for using these tools with great scientific integrity. And that should include providing feedback to model creators and AI researchers as to the needs. Scientific research needs well-calibrated confidences in inferences. We need to understand attribution. Where is the information coming from when syntheses and inferences are made, so we can properly cite, for example. We need to understand the possibility of using these tools in new ways and providing feedback to what the scientific goals might be as we move forward. I think would be very important in a two-way conversation between AI researchers and advancements, the scientists, and of course people who now are more and more wearing both hats at the same time.
Thank you for that. Well, the timing, you all, is perfect. It is now time to bring this report to a vote. And so all those in favor of accepting this report, please say aye.
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 Anyone opposed? Great. We have a new PCAST report. I also want to take an opportunity to thank everyone who was involved in this. It was a huge effort, and I think we have something quite useful for charting the future of AI in the sciences and in research. Especially want to thank Terry Tao and Laura Green, the co-leads, but Bill Dally, Eric Horvitz, John Levin, Bill Press, Saul Perlmutter, Lisa Sue, and Phil Venables, all of them who were members of the group. And I'm going to pass this now on to Maria. But before I do that, I just want to say congratulations to John Levin, our esteemed colleague here on PCAST, who has now taken on a really big job as president of Stanford University. So congratulations. Maria?
Yes, thank you.
All yours.
Thanks, Francis. And John, congratulations from all of us on PCAST. It's just a tremendous opportunity for you, and it's great for Stanford. So I'd just like to inform everybody that the report that we just voted favorably on is going to be formatted and copy edited before it's released, which is anticipated to be next week. And as soon as it's published, it will be on the PCAST website. So now we're at the public comment point in the proceedings here, and I would like to invite Dr. Brian Seeley to provide a public comment. Dr. Seeley, you've got 2 minutes. Dr. Seeley, we can't hear you. Are you on?
Okay. Can you hear me now?
Yes, I can. Great.
Thank you. Our 20-year accumulation study calculates that wildfires globally caused 101 gigatons of atmospheric CO2 in the year 2020. That 101 gigs clearly dwarfs the annual 40 gigs from fossil fuel use. The EPA says 101 gigs cost the planet $19 trillion per year. Climate summits have dismissed wildfires as untouchable nature, but the huge accumulation of their serial damage to CO2 sequestration is bringing horrific extreme weather disasters that won't quit unless we end wildfires. Now, the good news, American technologies can end wildfires in the US and across the globe. How? With next-gen aerial firefighting, nearly continuous bucket brigades of autonomous electric air tankers that arrive on scene 4 times faster, drop 20 times more liquid per hour, and douse wildfires within 30 minutes of their outbreak. Squadrons of emission-free aircraft operating from ubiquitous 3-acre air parks could fight fires 24/7, even at night and in heavy smoke. SustainableAviation.org has a feasible, affordable, and detailed plan to do that. Ending wildfires could save most of that $19 trillion loss and clean tens of gigs of CO2 each year, making it the single fastest and most effective way to curb the climate crisis. Now, the climate crisis makes that opportunity an urgent call to action. And fortunately, we together have the means to make it happen. Let's do this. Thank you.
Great. Dr. Seeley, thank you very much for that comment.
Thank you.
I would like to reiterate here that the recording of this event and the AI report slide presentation will be available on the PCAST website within the next week. Let me again congratulate the working group for just a tremendous report. And let's see, I'll invite Francis and Arthi to see if they have any closing comments here.
I just want to say I'm excited about the future. We have a lot of work to do in AI to make sure that it serves us, but I'm excited about the opportunities.
Great.
I'll just add my thanks to the working group and the whole PCAST group, because everyone has been engaged in that conversation. But thanks to the working group for pulling together into a really, I think, what will be a useful and impactful report.
Great. Well, thank you, everybody, and thanks to the general public who tuned in today. And I will hereby adjourn this meeting.